Hello, this is Dr. Paningrai. Welcome to my biology classes for medical entrance examination. In this video, I have a talk about the mammalian bone or especially the structure of mammalian bone. In my last video, I told about the structure of frog's bone, but here I am going to tell about the structure of mammalian bone because the structure of mammalian bone, it is slightly complicated than the structure of the frog's bone and then the other vertebrates bone. So as I told that in my last video, the each long bone of vertebrates, it has two regions. The head region of long bone, which is known as the epiphysis. This is the head region of the long bone. This is the head region, and such head region is known as the epiphysis. In between two epiphytic region, the middle portion of the long bone, which is known as the shaft or diaphysis. The shaft or the shaft or diaphytic region, the bone cells and matrix present densely and which forms the compact bone. In other words, at the region of epiphytic region, there is no compactness of bone cells of the matrix. That's why, which is known as the spongy bone. If you take the section of such compact bone, then we find that the compact bone, it has the central cavity, which is known as the medullary cavity or bone marrow cavity or the marrow cavity, which is filled with the bone marrow, as I told earlier. Around such medullary cavity, this is the bone matrix and the bone cells. The outermost covering of such bone, which is fibrous covering and contact with the vascular supply of the body, and this is known as the periosteum. Around the medullary cavity, there is the layer of cells, which is known as the endosteum. In between periosteum and the endosteum, this region, which is filled with the bone matrix and the bone cells. The mammalian bones are thick and larger in size. That's why the bone cell, they present in deep region of the matrix. That's why such bone cell cut off from the vascular supply of periosteum as well as endosteum. Suppose that here the bone cells are present. Here the bone cells are present or embedded in the matrix. And such bone cells, they cut off from the vascular supply of the periosteum as well as the endosteum. That's why these osteocyte cell needs extra supply of the vascular nutrition or the extravascular supply. So such need actually meet by the supply of blood capillaries in the matrix. So in mammalian bone, the bone is very thick. That's why the cells present in the deep of the matrix and they cut off from the vascular supply of the peri and the endosteum. That's why they need the extra vascular supply. So need of extra vascular supply, such matrix contain the wide spread of capillaries, and such capillary run inside the matrix through the channel or the canal. And such canal or the channel are two types. Some channels are parallel to the long axis of the long bone, and such channels or the canal is known as the Haversian Canal. And some canals, these are oblique or the transverse to the long axis of the long bone, and these are known as the Balkman canals. If you take the section, then we clearly understand how these Balkman canals and how these osteocyte cells are arranged here. As you know, in case of frog bones, the bone cells are arranged like this. Around the medullary cavity, these bone cells around like this concentric manner. That's why the matrix of bone cell divide into number of plates. So these are one lamella, this is another lamella, this is another lamella, this is another lamella. But in case of frog bone, in case of mammalian bone, there is the longitudinal canal. Suppose that this is the one longitudinal canal, this is another longitudinal canal, this is another longitudinal canal, this is another longitudinal canal, and such longitudinal canal runs parallelly to the long axis of the bone. And around such canal, the bone cell, the concentric layer of bone cells present around the longitudinal canal. And these longitudinal canal is known as the Haversian Canal, after the English physician or the anatomist, the Haversian. If you take the section like this, if you take the section like this, then we observe that this portion here, this is the outermost layer, this is the outermost layer. The outermost layer is known as the periosteum, which is one type of fibrous connective tissue. This is the periosteum. And this is the medullary cavity, which is filled with bone marrow. And around the medullary cavity, this is the layer of endosteum. Layer of endosteum. And this is the Haversian Canal. Suppose that this is the Haversian Canal here. And such Haversian Canal runs like this parallel to the long axis of the long bone. So this is the Haversian Canal, longitudinal canal. This is known as Haversian Canal. This is Haversian Canal. Around the Haversian Canal, there is the concentric layer of bone cells. So these are the osteocyte cell. Osteocyte cell, they have the canaliculi. As I told earlier, so these are the canaliculi. So these are the canaliculi. These are the canaliculi. Why canaliculi present in bone cell? The exchange of chemicals of bone cell takes place through such canaliculi. Such canaliculi, they connect to each other and they also communicate to the Haversian Canal. So through such canaliculi, the bone cell exchange their chemicals. That's why canaliculi number and the length and the branched in more in case of the mammalian osteocyte cell. So suppose that this is the one arrangement of the bone cells. These are the osteocytes. These are the osteocytes. Suppose that this is another Haversian Canal. So as I see, around the Haversian Canal, the bone cell concentric, about 20 number of concentric layer of bone cells are present. So suppose that these are the bone cells. They have the canaliculi. So these are the bone cells. Such bone cells have the canaliculi, and such canaliculi, they communicate to the Haversian Canal, and through which such osteocyte cell exchange the chemicals. So these are the bone cell arranged like this in concentric manner. That's why the matrix of bone also divided into number of plate-like structure. So these are the canaliculi, and they arranged like this. And by the arrangement of such osteocyte cells around the Haversian Canal, this is the Haversian Canal, the matrix of bone, so in between two concentric layer of osteocyte, this is the matrix of bone, and here the matrix of bone also divided into number of plates. Suppose that these are the number of plates, and these are known as the bone lamella. In plural, these are known as the bone lamellae. So these are known as the bone lamellae. It forms the bone lamellae. So, Haversian Canal, which runs longitudinally parallel to the long axis of the long bone, and these cells, osteocyte cells, they arranged concentrically around the Haversian Canal. That's why it forms a three-dimensional cylindrical structure inside the bone matrix. And such system or such structure, cylindrical three-dimensional structure of mammalian bone, which is known as the Haversian system. This is known as Haversian system, or it also known as osteon. Osteon. Somehow, osteon is known as the unit of mammalian bone. So this is the Haversian system. Such Haversian system, center of the Haversian system, that is the Haversian Canal. Around the Haversian Canal, up to 20 number of concentric layer of osteocyte cells are present, and the canaliculi of such osteocyte cells, they communicate to each other, and they also communicate to the Haversian Canal because of only easy exchange of chemicals of the osteocyte cell. So suppose that this is the one Haversian Canal and there is also another Haversian Canal. So many number of Haversian canals are present. Around such Haversian canals, the osteocyte cells are present. That's why the matrix of the bone or the medulla of the bone, which having so many osteons, that's why these osteons are known as the unit of the mammalian bone. And each osteon also communicate to each other. These Haversian canal also communicate to each other through the transverse of the oblique canal, and these are known as the Balkman Canal. Suppose that this is the Balkman Canal, and Haversian Canal. Such Haversian Canal run obliquely to form a branch and communicate with the nearby Haversian Canal, and such oblique canal is known as the Balkman's Canal. This is known as the Balkman's Canal. Such Balkman's Canal communicate to the Haversian to Haversian, and it also communicate to the periosteum as well as endosteum. So such Balkman canals, they develop from the Haversian Canal from a oblique, and which communicate to the periosteum, and it also communicate with the endosteum for the exchange of chemicals. So each Haversian canal communicate to each other or jointed to each other by a transverse canal or the oblique canal. These are known as the Balkman's Canal. Such Balkman canals also communicate with the vascular layer of periosteum or the endosteum. And it is you have to observe that such Balkman Canal as well as the Haversian Canal, they contains the one or two number of blood capillaries or more than two number of nerve vessels, but there is no lymphatic vessels. The lymphatic vessels only restricted to the periosteum. So up to this periosteum, the lymphatic vessels are present. But inside inside the bone, inside the Haversian Canal or the Balkman canals, there is no lymphatic vessels. So now up to this, we find that this is the bone structure and having the number of osteons. And such osteon, this is the total complete osteon. some of the mammalian bones, they remodulate throughout life. That's why the reabsorption of osteon and the formation of osteon again and again continue throughout life. That's why there is a gap in between the complete osteon and the absorbing osteon or the remnant older osteon. And in this gap, there is some of the osteocyte cells. Suppose that these are the osteocyte cells here, and this is the gap in between the complete osteon and the older osteon. And these osteocyte cells, those are present among these such gaps, and these osteocyte cells, these are known, and this region is known as the interstitial zone and interstitial osteocyte. So this zone is known as the interstitial zone. This zone is known as interstitial zone. So up to this we have two things. One is the osteon or the Haversian system in mammalian bone. Another is the interstitial zone. This is the zone in between the complete osteon and the older osteon. And here we also find another zone. This is known as the outer circumferential zone. So this is the outer region. Suppose that this is the one osteon. This is the one osteon. This is the outer layer of periosteum. So in between the osteon and the periosteum, this region, it has some osteocyte cells and the thin layer of matrix. So this is the osteocyte cells. Suppose that here two layers of osteocyte cells are present. These are the osteocyte cells. So these osteocyte cells present in between the periosteum, this is the periosteum, this is the periosteum, and in between the osteon, this is the osteon. And this layer is the thin layer and which runs longitudinally parallel to the long bone, and this zone is known as the outer circumferential zone. This zone is known as outer circumferential zone. This is the outer circumferential zone. This is the thin zone in between the periosteum and the osteon, and such zone runs parallel to the long axis of the bone. Like this, such type of thin zone also present in the inner side. Suppose that this is the inner region, and this inner region, it has the osteocyte, some of the osteocyte cells present. And these osteocyte cells, suppose that it forms a single layer of osteocyte. So these osteocyte cells which present in between the endosteum and the osteon, and such thin layer which also run to the parallel to the long axis of the bone, and this zone also known as the inner circumferential zone. So up to this, we know that the total mammalian bone, it has 4 zones. So one is the osteon or the Haversian system. Another zone is known as the interstitial zone. This is one interstitial zone. This is the 2. Another is the outer circumferential zone. This is the zone 3. And last one is the inner circumferential zone. This is the zone 4. So this is the arrangement of and the structure of the mammalian bone. I hope you understand it better. If you like, then click on my next video. Thank you for watching.